We are looking at the largest habitat on our planet, the ocean. Every change in the depths of the sea affects not just its inhabitants, but each and every one of us, even though this change is not yet perceptible. Water covers more than 2/3 of the surface of our planet, but many of the secrets from this unique habitat are still shrouded in mystery. Martin Fisbeck is one of those who would like to change all that. He is a spokesperson for a research association which has no comparable counterpart worldwide, the Future Ocean Cluster of Excellence. He knows that the oceans will play a decisive role in the future of humankind.
Wir haben uns vorgenommen, das Thema Ozean.
We intend to study the subject of the ocean in depth. We'll look at medicine, physiology, and discuss how the organisms deal with CO2. We'll look at how mathematics can help us to produce a better simulation of the ocean. We'll look at laws and discuss who really owns the ocean and the legal background. Maritime law is an exciting subject at the moment, and we'll also investigate the economic issues. Can it go ahead? Is it feasible?
One of the important topics of the cluster is worldwide overfishing. Whether it's caught in mackerel in the North Sea, in the Baltic Sea, or tuna, almost all traditional fish stocks are now under threat.
90% of the world's big fish are caught. European fishery is simply very inefficient and not managed professionally. If you look at the pollution along the coasts, that is a cause for concern. My generation will be able to sweep it under the carpet, but that won't be the case for my children.
Scientists need facts to determine whether these concerns are well-founded. For that reason, Kiel receives and analyzes data from the world's oceans on a daily basis. Each year, Martin Fisbeck spends many weeks on research vessels. One expedition will take him to the northeast Atlantic to the Cape Verde Islands. Additional measurement buoys called Argo floats are to be deployed there. There are currently over 3,000 of these devices in oceans worldwide. Researchers from Kiel have also helped to develop an ocean glider to carry out similar work. It sails hundreds of kilometers across the sea and transmits measurements via satellite to scientists across the globe.
It is so maneuverable that it can carry out a detailed scan of a particular bit of ocean. You can tell it exactly where to go, and that helps us to understand the smaller scale processes in the ocean. Argo gives us a global overview, and the glider shows us in detail what is happening in those regions and where the situation can quickly change.
But researchers are not just interested in the water column. They also investigate the seabed and bring samples from their expeditions back to Kiel. The sediment from the seabed is examined at the Biomarker Laboratory in Kiel's Christian Albrechts University. A PhD student takes samples from a 1.5-meter long drill core. This contains information that goes back millions of years. Such sediment samples are like an open book for paleoclimate researchers, and it can give them an insight into a time before human life started on Earth. The results of chemical analysis from such sediment samples allow researchers to reconstruct the prevailing climatic and weather conditions. This view of the past is intended to help understand natural climate changes and contribute to computer models designed to create a better understanding of the climate of the future.
This means that we can use the data obtained to give our modelers a tool to discover what has happened in the past, create models, and perhaps draw conclusions on future climate scenarios.
The greenhouse gas CO2 has a great influence on tomorrow's climate, and it is already changing life underwater. Carbon dioxide emissions that escape into the Earth's atmosphere will not just warm up the ocean in the future, but will also make it more acidic. The continued high levels of CO2 emissions caused by humans will probably make this acidification increase more rapidly than ever before in Earth's history. For organisms with calcium carbonate-based shells, such as clams and mussels, the acidic seawater makes life difficult. Biologists in Kiel are researching the effects of water with different pH values on the shells of such creatures. The increasingly acidic conditions restrict their growth and can, ultimately, dissolve their shells. The extinction of certain marine organisms can also change human living conditions forever.
The productivity of the ecosystems is naturally a factor that feeds back directly on the economy. For example, when a food chain breaks down, certain types of fish are no longer available in the same quantities as before. This would obviously lead to a decline in the catching of the fish fleets and would, of course, have an immediate and serious effect on human beings.
The changes in the oceans do not just bring risks for human beings. The world seas also present medical research with new opportunities to investigate previously untreatable diseases.
We're looking at a group of relatively new diseases. They have only existed since the start of the last century. Of course, one must wonder what these very old organisms have to do with these new diseases. We have made good progress in identifying the risk genes, and we were very surprised to discover that only the very old genes are associated with the evolution of these diseases. The genetic flaws that we've identified as flaws today were created some 35 to 40,000 years ago. They may have served as protection against particular diseases which may not even exist anymore. At the same time, present living conditions make them a possible risk for diseases that we see today.
A huge area of research brings scientists together in the Kiel Cluster of Excellence. Although they belong to a wide range of disciplines such as natural sciences, information technology, economics, law, or medicine, one goal unites them all: understanding the ocean to sustain our future.